Hey Algebra 1, here are your notes for 12.7 day 1. We're going to be adding and subtracting rational expressions, but today we're going to be doing that with unlike denominators. A quick warm up here in the bell work, that's with similar denominators or with like denominators. I have every confidence you can handle those on your own, so we're just going to jump right in. Before we are able to solve with unlike denominators, we should really refresh our arithmetic skills. So given a number c, what can I multiply by c where the product is still c? Now this isn't a trick question, I promise. Think about it for a minute. And then if you can't get it, let's write an algebraic equation that looks like this. What number, x, can I multiply by c where the answer is still c? Well, if I solve this by dividing both sides by c, that cancels them on the left side, and on the right side we get c divided by c, or just 1. So the number that can be multiplied by c that doesn't change it is just 1. And 1 can look a lot of different ways. X can equal 1 here. Another way of writing 1 could be 1 over 1. Or 2 over 2, or x over x, anything divided by itself. And this is something that we are familiar with based on other lessons, but it's good to refresh that. So let's now apply this idea. Are the following fractions equivalent? And the hard part here isn't determining if they're equivalent, it's then being able to explain why or why not. So in this first one, we should all know that 1/2 is equal to 3/6. It makes sense to us because we've worked with fractions before. But the reason behind it is a little bit more tricky. If you've worked with equivalent fractions, you know that in order to get an equivalent fraction, you have to multiply both the top and bottom by a number that gives you the larger version of what you started with. So in this case, 1/2 is multiplied by 3 over 3 in order to equal 3 over 6, which is equivalent. The reason it's equivalent is because all we've done is multiply by a fancy 1. It hasn't changed our equation at all. It hasn't changed the fractions. It has just made it look different. And we need to keep that in mind as we go through this unit. So is 1/2 equal to 2x over 4x? The answer is yes, because we have multiplied by 2x over 2x in order to get 2x over 4x. And when we did that, it's the same thing as multiplying by 1. And we know that doesn't cause any issues. Same thing with the next one. I find that multiplication is x over x. That's just multiply by 1, so we're good to go there. However, this next one's a little tricky. If I look at the denominator, this tells me I'm multiplying by xy. Multiply by xy. But if I look at the top, this is telling me I'm multiplying by x plus y. That is not equivalent to 1. So this is not equivalent. So not equivalent. And we proved that by saying if we're not multiplying it by 1, it can't be equivalent. Same thing with this next one. What is my equivalence factor here? Well, on the top I multiplied by x plus 1 times x plus 2. On the bottom I multiplied by x plus 1 over x plus 2. That's the same thing as multiplying by 1, so we are good to go. X plus 1, x plus 2. As long as it's the exact same on the top and bottom, it's the same thing as 1, and we're good to go. So another relevant riddle here, if you are asked to find the least common multiple between two terms, what does that mean? Well, I'm going to write it out in words. I think that's the easiest way to do it, but I think you will be able to understand it better once we start applying it. But I do want to write it down. So, what does that mean? First off, we're going to find the prime factorization. Prime factorization of each. Remember, this is where we break it down. This would be our tree. Once we have broken it down, we're going to use each factor from both of them each factor the max number of times it appears. And you're like, I have no idea what you're saying. That's okay. Let's look at some examples. I think it'll make a little bit more sense. So if I give you the numbers 4 and 7 and I ask you, what is the least common multiple of these? You're going to start thinking, well, 4 times 2 is 8, and that doesn't have anything in common with 7. You're going to start going through your multiples of each. Maybe you even write them out, 4, 8, 12, 16, so on and so forth, until you find where they meet up. But that is not the easiest method. So I want to show you an easier way than just listing them out. First, find the prime factorization. The prime factorization is 1 times 4. The prime factorization of 7 is 1 times 7. Based on my explanation from up above, we're going to use each factor the max number of times it appears. Okay, that's where it can get a little confusing. Let's start looking at our factors. 1 is a factor of both. The maximum number of times it appears in 4 or in 7 is just 1 time. The max number of times 4 appears in 4 or 7 is 1 time. We've already used a 1. We're not going to use it again. So the max number of times 7 appears is once in both 4 or 7. Now that I've taken each factor, the max number of times that it appears, I'm going to multiply them back together. 1 times 4 times 7 is 28. And I guarantee that if you listed out your multiples of 4 and 7, the first multiple that they would have in common is 28. Now, if you like listing out all those multiples, go for it. I love that you found a method you like. However, I'd like to suggest that as we keep going, you start to get into using this method, especially when we start looking at challenges like this one coming up. This is going to be really hard to write out multiples of, but it's going to be a lot easier if we use this. So let's keep going here. We've got 15x and 3x. Right away, going to list out my prime factorization. 3 times 5 times x, and 3x is just 3 times x. The max number any of these numbers occurs is once. So we're going to take 1, 3, 1, 5, and 1x. And when we multiply those back together, we're just going to get 15x. So in this case, our least common multiple is 15x. The next one is going to be an example where you could take it a max number of times. These ones are easy because they just have one of each. This is a little different. So first term, I'm going to bring that down. My prime factorization is 3 times m squared times b cubed. I know I said prime factorization, but I don't like listing out those letters, and I'm going to be able to tell where the max number of them occur based on their exponents. So I'm not even going to worry about listing those out. 18mb is going to come down here in the second slot, and that's going to be 2 times 3 times 3 times m times b squared. All right, let's start looking for the maxes. I've got a 3, and the max number of times that it occurs in either one of these is 2, so I could take them from the first or from the second. In this case, I'm just going to take them from the first. I've got an m in both. Which one has the max number of m's, however? That would be this top one. It's got 2. That is the max number of times it appears, so I'm going to take that. For my b, the max number of times it appears is 3, because 3 is bigger than 2. So I've now accounted for my 3's, my m's, and my b's. The only thing I have not taken account for is this 2. So this explains how I have taken the max number of each. Let's bring those down and multiply. So I've got a 2, 3, 3, m squared, b cubed. And then I'm just going to simplify that. 2 times 3 is 6, 6 times 3 is 18. So my least common multiple here is 18m squared, b cubed. because I took the max from each of those and I put it into my LCM. All right, we're getting a little bit more tricky here, as you can see, but do not freak out on me yet. If I give you 3x minus 6 and I ask you to list out the prime factorization, you're like, no, that's a binomial, it can't be done. Here's the thing, prime factorization is just whatever you're given in the form of multiplication. So how could we rewrite 3x minus 6 with multiplication involved? Well, you should notice that 3 and 6 are both divisible by 3. So one way I could rewrite this as multiplication is by factoring out a GCF of 3. When I do that, I get 3 times the quantity x minus 2. That is now in prime factorization because it's in the form of multiplication. Let's do the same thing for 2x minus 4. I notice they both have a GCF of 2, and when I factor that out, I'm left with x minus 2. Now that I have this, now that I have that prime factorization, I can use each factor the max number of times that it appears. The number 3 appears 1 time, so I'm going to take that. The number 2 appears 1 time, so I'm going to take that. The max number of times that x minus 2 appears in the first term or the second term is just 1 time. So I'm going to take that. Let's put it all back together. 2 times 3 times x minus 2. Simplified, we end up getting 6x minus 12. And that is our least common multiple. All right, challenge time. If I give you the term x squared plus 8x plus 15 and a second term of x squared plus x minus 6, the first thing you're going to do is write out the prime factorization. And that's going to look very similar to this problem here. So why don't you go ahead and pause the video, take a minute to see if you can do the first step, finding that prime factorization of both terms. If you get that, go ahead and try the second step. Otherwise, come on back, we'll do it together. All right, hopefully you had a chance to at least try for step 1. If you got step 2, awesome. If not, totally okay. To find the prime factorization, we're going to need to factor this. Factoring involves those 2 parentheses that we're used to. No number out in front means I don't have to do an x puzzle. I can simply write x and find what multiplies to 15 and adds to 8. In this case, a positive 3 and a positive 5 will do it, and that is now in prime factorization form. Second term, x squared plus x minus 6. Same thing, no number in front, no x puzzle needed. X, this is always a tricky one with this negative 6. It seems to trip people up. It's okay. In this case, it's going to be 3 and 2. And because this middle number is positive, the bigger number is positive, the smaller number is negative. All right, now if you didn't already, we're going to use each factor the max number of times. All right, does x plus 3 show up more than once in my second term? No, it only showed up 1 time, so I'm going to take it once. X plus 5, it only shows up once, so I'm going to take it once. X minus 2 only shows up once in either, so I'm going to take that. So now that I've taken those in their max number, let's bring them down. X minus 2 times x plus 3 times x plus 5. That is our least common multiple of these 2 trinomials. I know that looks really big. You could multiply this out now and get a trinomial. Not a trinomial. In this case, it'd be a polynomial with 4 terms. But I'm going to leave it like this just because all the problem asks for is to find the LCM. It doesn't tell me what form to put it in. But the real question is now, can we utilize all of the information that we just reviewed in order to add and subtract rational expressions with unlike denominators? Well, let's find out. This first one, how are we going to approach this? Well, I've got 1/2 on one side, and I've got 3a on the other. The first thing I should do is find that denominator that they have in common, which in this case is going to be the least common multiple of 2 and 3a. So the way that I do this is I write down my prime factorization of each. I do the same thing again for the second one, and then I say my least common denominator. I take a 1, a 2, and a 3a to be 6a. And once I have my least common denominator, now I have to recreate that denominator on each side. 7, 3a. So how do I get a denominator of 6a on the left-hand side? Well, in order to change a 2 to a 6a, I need to multiply this side by 3a. However, this is where our first riddle came in. The only way to change a fraction without actually affecting it in any other way than changing how it looks is by multiplying the entire thing by 1. Whatever you do to the bottom, you have to do to the top, because when we do that, we now get 3a over 6a, which we know is equivalent to 1/2. All right, second fraction, how do I get to 6a on the bottom? Well, I have to multiply by 2. But whatever I do to the bottom, I have to keep it balanced and do it to the top as well. So the right fraction becomes 14 over 6a. Now that I have these fractions with a common denominator, I can add them the same way I did in the previous videos. Add across the top, and put it all over that new lowest common denominator. And there you go. In this case, this one can't be reduced or simplified in any way, so that's my final answer. All right, let's see the next one here. 1 over 6x plus 3 over 8. Again, I'm going to take my first denominator, write out that prime factorization. Second denominator, write out that prime factorization. Take the max number from each. Do I take 1 2 or 3 2s? I'm going to take the maximum number that I can. So in this case, I'm going to take all 3 of those. I only have 1 3 to give, 1 x, and then 1 1. So my least common denominator in this case is 3 times x times 2 times 2 times 2, which is 8. So overall, my lowest common denominator is 24x. I'm going to show you that again with the denominators. How do we make 6x become 24x? We multiply it by 4. But whatever we do to the bottom, we do to the top. Same thing over here. How do we go from 8 to 24x? Well, we have to multiply by 3x. But again, whatever we do on the bottom, do on the top. And now let's simplify. 4 over 24x plus 9x over 24x, and add. I'm going to put it down here. 9x plus 4 over 24x. Boom. Just like that. And I can't reduce or simplify, so that is my final answer. All right, next one looks a little bit tricky, but I do want you to pause the video, take a shot at that one if you can, and then come on back, we'll do it together. All right, hopefully you gave that one a shot and you are back. Let's look at how this one pans out. So I'm not gonna write these two pieces every time. In this case, I'm gonna just write the LCD, because as you get faster, you won't need all of these steps. So in this case, LCD, I will need an x squared over here, and I'll need a 9 over there. So eventually my least common denominator will be 9x squared. if you still need a little bit more practice on LCDs, hit me up. I'd love to help you out with that. All right, left-hand side, we have 5 over 9x. How do we go to 9x squared on the bottom? We're going to multiply this side by x over x, which is just a big fancy 1. We minus 1 over x squared. How do we go to 9x squared? Well, we multiply by 9 over 9. And then this gives us 5x over 9x squared minus 9 over 9x squared. Subtract across the top. 5x minus 9 all over 9x squared. There's your answer. All right, if you're feeling confident about that one, these last two are very similar. In fact, this is the exact same one. I must have written it incorrectly. So we're actually just going to go ahead and skip that one altogether. You lucky ducks. All right, try that last one on your own and then come on back. We'll do it together. All right. So let's go ahead and go with this one. Let's start off finding the LCD, in this case lowest common denominator. This one has x squared, that one has x cubed. In order to get from an x squared to an x cubed, I'm going to have to go all the way up to x cubed. That means on the left side I'm going to multiply by x over x to get 6x over x cubed. On the right side, I don't have to multiply anything because I already have my lowest common denominator. So 3 over x cubed stays as it is. And then just subtract 6x minus 3 all over x cubed. All right, and then as I looked at this next one, I did notice there was a difference between this one and this top one. The only difference, however, was this was a subtraction problem, this was an addition problem. The whole process stays the same, and the only difference is at the end of the day, this will be an addition sign instead of a subtraction sign. So that is how you do that last problem. Go ahead and give your homework a shot, and if you have any questions, please don't hesitate to let me know. I'd love to help you out.